Well, dear friends, in the last lecture, we have completed structure of this polysaccharides, cellulose, starch, right? And this is in your syllabus basically. And disaccharide, glucose, sucrose, maltose, and galactose, right? Now see, there is one reaction or rearrangement we can say, Lowry D. Brown Alberta Van Eknisten rearrangement. See, if you see, uh, ketohexoses like fructose is also, reduces the tolerance and failing reagent. So how this can be explained that tolerance and failing are reduced by uh, ketohexoses, although there is no aldehyde group in fructose. So fructose is a reducing sugar. This you can explain on the basis of this rearrangement. If you know this rearrangement, then you can very easily justify why. So this is a good reaction to justify why why fructose is reducing. Fructose is reducing sugar, right? Why fructose is a reducing sugar? Okay. See, if we have this structure, as all of you are knowing, CH2OH. If you take this D-glucose, and you know, in Tollens and Fehling reaction, the medium is basic. So under basic condition, this D-glucose under basic condition, if you remember, then in tolerance reagent, what we are taking? Ammonical silver nitrate. So ammonical means ammonium hydroxide, right? Ammonium hydroxide with silver nitrate. The medium is basic. If you take Fehling solution, so sodium potassium tartrate, alkali, and copper sulfate. So purposely we are taking alkali in the medium alkaline in case of Fehling solution. So that alkaline medium, this is a basic medium. So all of you are knowing that the alpha carbon of carbonyl compound, so this is alpha carbon, although this is not purely alkyl group, but this is hydroxy substituted alkyl group. So this hydrogen is acidic. Alpha hydrogen is acidic. All of you are knowing. So in basic medium, this hydrogen releases, and this will form, in diol, right? So how this will form? H plus will remove from here. Negative charge will come here. This negative charge will come here, and this bond is shaped like this. So I am showing two step in one step basically, because I am not showing here the loss of proton. Directly I am showing here. So and this O negative and H will join here. So you are getting here C double bond C OH. This OH is already there. H uh, and rest part is same. rest part is same. Now if you can see, this is sp2 hybridized, this carbon is also sp2. Now this can be, reversed, and in the reversal of this, we may have two different products. How? See, suppose that this hydrogen, this hydrogen will move like this, right? So the movement of this bond has two orientation, that this OH may be this side or this side. So because this is sp2, and this bond will go like this, right? So negative charge will come here, and here double bond, so this will convert into the keto sugar. So what we will getting, and here negative charge, and this H will come here, so we may get OH, H, H, and CO, and rest part is same. So what we are getting? Basically, we are getting here fructose. We are getting here fructose, right? So this is a D fructose, D fructose. And when this hydrogen involves in the, reaction, so what will happen? So this is number one path, this is number one, so this is number one, and now I am writing this is number two. So if this hydrogen involves, this bond will come here, so this OH may be this side or this side, right? So if this is on the same side, then you will get glucose, and if OH will come this side, then this is mannose, then this is mannose, and this is the reason why glucose, fructose, mannose all forms same OSA zone also, and all are reducing. If you are starting with the fructose, this fructose will convert this ene diol. This is called ene diol, right? So this fructose is converted into enediol into glucose, and this glucose shows the reduction of, causes the reduction of tolerance and failing, right? So when this carbon number two, hydrogen number two, this will involve in the tautomerization. Basically, this is a tautomerization, right? So what will happen? One possibility that this is in the same side of OH, so you will get glucose. Now this side OH may come, so COH, aldehyde group retains, but this time OH will come this side, H, and rest part is same. The rest part is same. So this is D-mannose, D-mannose, right? So D-mannose, D-fructose, D-glucose, they will interconvert into each other. So if the question is asked why this fructose reduces tolerance and failing solution, so your answer is like this, that fructose in basic medium converted into glucose, which reduces, which is aldehyde, and which reduces the tolerance and failing reagent. So what is the answer of the above question? The answer is in basic medium, in basic medium, fructose is converted into glucose and mannose, which are aldo sugars, aldoses, that is reducing sugar, right? So in this way you can explain why fructose is showing this reducing nature, right? So with this reaction, now your carbohydrate is over, right? Carbohydrate is over. Now next part of your biomolecules is amino acids. Amino acids. So see, as the name itself manifested that amino and acid. So carboxylic group is there. Carboxylic group is there. Acid means commonly in organic chemistry, if we are talking about acid, means carboxylic acid. And amino group, if both are present in the same molecule, then the compound is said to be amino acid, right? So if you see, this is a simple amino acid. This is carboxylic group and this is alpha carbon basically with respect to this COH group. This is the first carbon, so this is alpha carbon. So basically amino acid, or we can say alpha amino acid. Acids. I'm not telling that only alpha amino acids are possible, but only alpha amino acids are important to us, right? Only alpha amino acids are important to us. They are in your syllabus. That's why our main focus is alpha amino acids, not beta, not gamma, not delta, right? Every kind of amino acid is possible, no problem. But this is important. This is important for us. So our focus is mainly on this. So if you see, this is primary amino group at alpha carbon with respect to carboxylic group. So here, if you closely observe, so this carbon is alpha carbon is stereogenic, and this is very important. So can we say that alpha amino acids are chiral? The answer is yes. Again, a question arises that all alpha amino acids are chiral. The answer is no. There is only one alpha amino acid which is achiral, except one. All are chiral, right? So this is very important chemistry here. As per chemist, we are basically observing all these things, right? So there are 20 amino acids known, and all these amino acids are, important for humans, right? Total 20 amino acids are known. Total 20 alpha amino acids are known. And important for humans. right? And they are important for humans. And out of 20, 19 are optically active, 19 are chiral, only one is achiral. So one, except one alpha amino acid that is known as glycine, glycine, right? Except glycine, all are chiral, right? So only one amino acid, alpha amino acid, one alpha amino acid, glycine is achiral. This is achiral. Rest, right, are chiral. Means, so what should be the structure of glycine? So the glycine is basically CHH NH2 COOH. So you can say that this is the simplest amino acid, first member of the this series where R is equal to H. So this is achiral, this is achiral, and rest all 19 are chiral, right? This is one observation. Second observation is, like carbohydrates, capital D and capital L naming is also popular in amino acids, but natural amino acids are L. Amino acids have configuration, relative configuration, not configuration, relative configuration to the stereogenic center, to the stereogenic carbon, what L, right? Means if you compare with glyceraldehyde, this is your reference. I mean, not only yours, this is mine also. Right D, OH left L. So similarly, alpha amino acids, if you draw the Fisher projection formula, so definitely COOH will be on the top. Why? Because there is a rule in Fisher projection formula that most oxidized groups should be on the top of the vertical line. And if NH2 is here and H is here, R is here, because longest carbon chain should be on the vertical line. So this is D amino acid. D amino acid. Means you have to compare NH2 with OH. So since in the Fisher projection formula, OH on the right, so this is D glyceraldehyde. So if in the Fisher projection formula NH2 is the right, like this, then this is the D amino acid, and this is not the natural amino acid. The natural amino acid is N, COOH, and R, NH2H. So this is L amino acid, and this is natural. Means in the plants, animals, humans, whatever amino acid is, we are observing, particularly in human, that is L amino acid, right? So this is a natural amino acid is L, which is abundant in case of humans, right? So total we have 20 amino acids, right? Except one, all are chiral. Glycine simplest, this is achiral, and one more important property regarding this. See, this alpha amino acids are the monomers. Monomers. Monomers means repeating unit, right? Monomers means repeating unit for proteins, proteins and polypeptides, right? So alpha amino acids are amino acids are monomers of monomers monomers of what? Monomers means repeating unit for proteins and polypeptides. If n is more than 100, means if 100 or more, more than 100, more than 100 alpha amino acids are condensed with each other, then they form protein. And if 100 or less, then this is polypeptide, right? Then this is polypeptide. So there is a clear cut distinction that we basically protein are high molecular weight compounds. That's why we are it is classified like if 100 or more amino acids are there, units are there, then this is called protein. So obviously this is high molecular weight compound, right? So in this regard, amino acids are very important. Okay. Now see one more important property that the question arises that I have written here as far as chemistry is concerned, that I have written here primary amino group. In every structure I have written a primary amino group. The question arises that all alpha amino acids have primary amino group or some have secondary or tertiary, like that. So the answer is no. Not all have primary. There is one amino acid out of 20 that has secondary amino group and none have tertiary. So we can write that mostly means 19 have primary amino groups, but there is one alpha amino acid which have secondary amino group, right? So we can write here that except one except one alpha amino acid, which one is that? That is known as proline, right? This has a secondary amino group, alpha amino group, NH, right? So if you see, this is chiral. This is chiral, and this nitrogen is secondary amino group, right? So except one alpha amino acid, that is proline, right? rest have primary amino right? So these are the, I mean, informations. These, I mean, maybe the important because this is something different because all 19 have NH2 group, but one have this NH group. So these type of questions may be, I mean, important. Now see, one more classification of amino acid is that essential amino acids and non-essential amino acid. So how they are classified? What is the basis of this classification? See, essential means, I mean, you can say the amino acids which are not synthesized in human body. See, all 20 amino acids are required in human body for various kinds of physiological actions and biological reactions. All 20 amino acids are required. All are important. But some of them are synthesized, directly synthesized in our body. So they are said to be non-essential because they are present in our body and our body itself manages that. But those amino acids which are not synthesized in human body, they are said to be essential, and we are dependent for that on the food, external source. So the external source is what? Food. So essential amino acids, essential amino acids, and I think this is all, this is listed in your NCRT book. You can go through the name of those essential amino acids. Essential amino acids. See, by default, I am not writing here alpha amino acid because amino acid means alpha amino acid, right? Here in this chapter. So essential alpha amino acids are not synthesized in human body. In human body. So these are not synthesized in human body, and I mean there are total 9 such amino acids are known. So 9 amino acids, they are essential for humans, and human is dependent on the external source for those 9 alpha amino acids, right? And rest 11 are said to be non-essential, right? Non-essential. So this is basically amino acids. They are synthesized in human body, and they are total 11. So total 11 amino acids which are non-essential, which are synthesized in human body, and there are 9 which are essential, which are not synthesized in human body. Clear to everybody? And now you can go through the name of those amino acids, right? Now see chemical classification, right? So chemical classification. So chemically amino acids are classified like acidic amino acids, basic amino acids, and neutral amino acids, right? So acidic, basic, and neutral. So in this way, you can classify, I mean, chemically, the amino acids, alpha amino acids. So chemical classification, chemical classification, chemical classification. So number one, acidic. So acidic amino acids, they have more than one acidic group. They have more than one acidic group. So I am taking this general, structure R CNH2 COOH R and H, right? So if R is equal to, if you put here R is equal to this R is equal to CH2 COH, right? R is equal to CH2 COH. So put here CH2 COH. So you have COH. This is the fixed skeleton, and CH2 COOH, right? This. This compound is known as aspartic acid. Aspartic acid, right? This is aspartic acid, and three-letter symbol ASP you can use. Three-letter abbreviation is used here. So this is basically R. This portion is R. If you want to rank here different, acidic groups. So this is most acidic. After that, this, right? Because this electron withdrawing groups are there at this, so this is more acidic than this. So this is acidic amino acid, aspartic acid. Now, second, if you take R is equal to CH2 CH2 COOH. So your formula becomes like this: CNH2H COH. This is fixed. Now this CH2 will join here, then CH2, then COOH. See, two acidic groups are there. So the aqueous solution of this is acidic, and this is acidic amino acid, and the name of this is glutaric acid. Glutaric acid, right? And three-letter symbol you can use GLU. So these two are acidic amino acids. Now come to the basic amino acid. Number two, basic amino acids. Basic amino acids. So first is, if you take R is equal to N, right? CH2 and here H. So if R is equal to this, so you have to add this CHNH2COH, CHNH2COH here. This is the R. This is the R. So this compound is known as what? Histidine. histidine, right? 3-letter symbol is HIS. If R is equal to, if R is equal to CH2 whole 4 NH2, means you have to add here CH NH2 COH. Then the compound is lysine, right? LYS, lysine. If R is equal to, all these are basic, because more than one NH basic group is there. See, N groups are there here, NH2 is there, right? Now if R is equal to CH2 whole thrice NH NH NH2. See, remember this group, this is guanidine. Somewhere in acidic and basic strength I have discussed this guanidine. So if R is equal to this, so many nitrogen are there, so many basic groups are there. So this is what basic amino acid. So this is arginine. The compound is arginine. Arginine. ARG. ARG. Right. So this is basic amino acid, and next, if R is equal to CH2 CH2 CONH2, right? So in the side chain there is a amide group. This is also basic, basically. So this is what, glutamine, right? Glutamine, glutamine. And if R is equal to CH2CONH2, then this is aspargine, ASP, right? So this is also amide linkage, but overall this is basic amino acid. So if you see uh, this, they are basic family, basic group. Although amides are very less basic compared to the NH2, right? So these are the basic amino acids. Some amino acids with the aromatic group. So amino acid with aromatic group. Third classification, this is second, basic, then amino acids with aromatic group. With aromatic group. So in this way, you can, little bit remember the things. If R is equal to CH2PH, so this is phenylalanine. Remember phenylalanine. In exam, due to pressure, all of you are read this aniline, right? Phenylalanine, alanine and aniline. In examination pressure, this will looks like that, and many students are doing mistake here. So be careful. When R is equal to CH2 OH, then this is tyrosine, right? So the fourth one is normal amino acid having only one NH2 group and COH group. So normal amino acids, right? So if R is equal to H, then this is glycine. If R is equal to CH3, then this is alanine. If R is equal to CH2SH, so this is what, cysteine. If R is equal to CH2CH2 SME, then this is methionine. So see, these two have sulfur, have sulfur, right? So this type of questions may, may be framed that which one has the sulfur containing what amino acid, right? So this is all about the classification of what alpha amino acids, right? Now see this cysteine, very interesting. Cysteine and methionine, these are very interesting. Alpha amino acids. So, here basically keratin protein. Keratin protein. Protein means water insoluble. Water insoluble. So in the same chapter, same topic, I will discuss when a protein becomes water soluble and when protein becomes water insoluble. Although proteins have this polar groups, COH and CO and NH, all these groups are present in protein. Although it is what water insoluble, like hair and nail, all they are proteins, keratin protein, water insoluble. But if you see, in your circle, so you will find your some friends, your friends here is very straight, very you can say clear, there is no curl, right? And some of your friends may have this type of curl. So basically those who have curls in their hair, this cysteine and methionine amino acids are more abundant, and this sulfur is free here, SH is free, so this S and S disulfide linkage is there. So if your hair is rich with respect to disulfide linkage, then it becomes curly. So curly hairs has this chemistry that they have this cysteine, alpha amino acid in their hair, and composition of this protein changes. Not every system have same composition of protein. Means every hair, means my hair and your hair not necessarily have same composition of alpha amino acids. We both are different. So if we are different, means everything is different. So when we are talking about at molecular level, lot of difference is there. So don't expect that everyone's hair has the same composition. No. So if a person have composition, hair has more this cysteine, more disulfide linkage is there, so more curly hair is there. He or she have. So curly hairs means more disulfide linkage. When you go to the parlor and to make the your hairs straight, so there are two methods. Either the only one method that if you are able to clean this disulfide linkage, somehow your hair becomes straightened, right? So either heat treatment you can give or some chemical treatment you can give. In chemical treatment, some oxidizing agents can be put here. So if you put H2O2, like this is a, I mean, human friendly chemical in dilute strength, so not harm your skin or any part. So this H2O2, a good oxidizing agent, can be used to break this disulfide linkage. And if you are able to break all these disulfide linkages, your hair for some time, your hair becomes straight. So this is the chemistry of what? Parlor. Everywhere is chemistry. So in parlor also, I mean, role of chemistry is there. Okay. So H2O2 is a good oxidizing agent, and it can be used to break the disulfide linkage present in the hairs so that your hair can be straightened, right? So this is all about the classification and general introduction of alpha amino acids, right?